This video is going to cover topics for converting rational numbers. A rational number is a number that can be expressed as a fraction. So let's go look at what a rational number is in detail. Remember, it's basically a number that can be expressed as a ratio of two integers. Simple terms, it can be written as a fraction. So always a fraction or a mixed number is a rational number. Integers are rational numbers. Terminating decimals, those are rational numbers. They end. We can convert that into a fraction based off its place value. Perfect roots, and I say perfect roots. Here you have square roots and cube roots. Those are going to be the ones we're going to focus on this year. So a perfect root, for example, the square root of 25. I know the square root of 25 is 5. Therefore, it now is an integer, so I can make it a fraction. And then finally, a repeating decimal. A repeating decimal can be made into a fraction, and we're going to see that today. So we're going to get asked to compare these numbers. Sometimes they'll be written as a decimal and a fraction. We can't compare them until they're written in the same form. So let's go look at that. So it's best that we rewrite numbers so that we can compare them. So when we're asked to compare, when we're looking at 1/3 or 0.366, which is 366 thousandths, I can't tell you which one is greater or less based off just looking at these. So I'm going to need to rewrite them. And in order to decide, they need to be in the same form. You need to know how to convert from fraction to decimal and decimal to fraction. Depending upon what you're given, it's important to be able to go both ways. So let's convert fractions to decimals. 1/6. How do I do that? I'm going to divide. This little fraction bar tells me to divide. When I divide, I'm always dividing my numerator by my denominator. What does that mean? Top by bottom. You have to think of this as a house, or let's think of it as a store. Okay? Your number 1 is like the cowboy riding a horse. Your horse can't go into the store. So who's going to go inside? The 1 or the 6? That's right. The 1 is going to go inside the store, and the 6 is going to stay tied up outside. Okay? Now, when I look at this, 6 cannot go into 1. So that means I'm going to have to put a 0. Well, that's not going to help me. Behind every whole number is a decimal, even if you don't see it. There's a saying I have: when the decimal's out of sight, place it on the right. So we're going to place our decimal here on the right side of my 1 so that I can now start adding more zeros. But before you do that, because this happens all the time, bring that decimal point straight up so that it's going to be there in your answer. And behind that decimal is a 0. We don't write it. It's imaginary because once it's gone, we don't need to write it. But that allows me now to ask, how many times does 6 go into 10? 6 goes into 10 one time. What is 6 times 1? 6. So I subtract 6 from 10. That leaves me with 4. Now, in the past, we had remainders. We don't have remainders because behind that 0 we've already written is another 0. So I can bring it straight down. So now I'm dividing by 40. Or how many times does it go into 40? Well, 6 goes into 40 6 times. 6 times 6 is 36. So I'm going to subtract that to get 4 again. So this starts signaling something in my brain, and it needs to start signaling something inside your brain. If you're going to keep getting 4, well, then you're going to keep getting 6 on the top. That means this is a repeating decimal. I can put the bar over my 6 because the 6 is what's going to repeat. You're going to keep going in 6 and 6 and 6. So you are done. Okay? So now it's your turn. Pause and try and convert these numbers on your own. Okay, let's see how you did. So 3/8. I'm going to put my 3 on the inside and my 8 on the outside. Obviously 8 can't go into 3, so I have my 0. Decimals out of sight, place it on the right. Don't forget that it needs to also be placed in your answer up top. So I'm going to add a 0. So now I can ask, how many times does 8 go into 30? Well, that goes in 3 times. So I subtract 24. 30 minus 24 is in fact 6. I am not going to leave it as a remainder. I'm going to add another 0 and bring it down. So now I'm asking, how many times does 8 go into 60? Well, we all know it goes in 7 times. So I'm going to subtract 56, and I'm going to be left with 4. Again, don't write a remainder, and don't just write 4 up there, because you're going to add another 0, bring it down, and ask, how many times does 8 go into 40? Well, 8 goes into 40 5 times, and you're left with 0. Okay? So in this case, 3/8 is 375 thousandths. Okay? That is your answer. It will always be your answer. So if you commit some of these to your memory, it'll make it a little bit easier. Some of you might be sitting there saying, well, I'm just going to take out a calculator and type it in. Okay, sometimes you'll be able to do that. You have to make sure you're putting the right number in the calculator first. But I can almost guarantee that you're going to have an assessment at some point. Something like this will be on it on a non-calculator day. So you need to know how to do this skill. So let's go and try 2/5. Obviously, I'm going to start with my house. 2 is going to go inside. 5 is going to stay outside. 5 can't go into 2. So I'm going to put my 0. Please put your placeholder. Then write your decimal. But don't forget to also bring that decimal straight up. Now that you've placed the decimal, you can add the 0 behind it. 5 goes into 20 4 times. So I'm going to subtract 20 and place my 4 above. The order in which you write it above doesn't matter. Notice on the other ones, sometimes I put the number on top first. Sometimes I subtracted. My advice, write it on top first. So 2/5, that's actually an easier decimal. And 2/5 will always equal 4/10, no matter what. So there is some benefit to memorizing what some rational numbers are as decimals, and it saves you some time. I'm not saying spend forever memorizing them, but have a good understanding of what they look like. All right. I think decimals to fractions is a lot easier. But before we can do that, let's go back and review our place value chart. Okay? So if we take a look here, we're not focusing on everything, okay? All we are focusing on is our decimals. For this year, in the math we're at, we're really only going to go up to the thousandths place. You don't have to say 1,000ths, but that's its place value. Your values that you have to understand too are tenths, which is right after the decimal place. Then hundredths, which is 2 after the decimal place. And finally, thousandths, which is 3 after, okay? So keep in mind those place values. So let's go look at what it is to convert decimals to fractions. So if I were to read this decimal, a lot of you are probably saying, oh, 0.9. You're right. You're not wrong in that. However, that's read properly. It's 9/10. So you could write it as 9/10. You just made it a fraction. If you understand your place values, it's going to make this process a lot easier. The thing you must always remember, though, is to simplify. 9 and 10 have nothing in common but 1, so I am done. So there's a little trick I have. How many numbers were after the decimal point here? 1, right? So that means I'm going to put 1 0 on the bottom. Okay? So that's one way to remember it if you can't remember how to actually say it. And you'll see what I mean by that with this next example. So now I have 0.36, which is most of you are probably saying, really, that's 36 hundredths. Notice what I just said, 36 hundredths. So I can write that as 36 hundredths. Plain and simple, right? Remember what I said on the last one. It's a fraction. Fractions always must be written in simplest form. If I look at these two numbers, the first one that probably jumps out to you is that you can divide both by 2. That's right. So if you divide both by 2, you're now at 18 over 50. But those can also be divided by a 2 again. So that really this equals 9/25. Okay, because the numbers are really both divisible by 4. So here's what I mean by my trick. There were 2 numbers after the decimal place. So you're going to place 2 zeros after the 1 on the bottom. That's another way to memorize how to make a decimal a fraction. Its place value, how far it is from the decimal, is how many zeros go there. Okay, but you always have to simplify. Finally, let's look at this last example because I told you you're responsible for 3 place values. So I've got 0.375. I'm hoping all of you are now saying 375 thousandths versus 0.375 because that's going to help you write your fraction. Well, there you go. 375 over 1,000. Now, this is also something to start committing to your memory. If it ends in a 5 and ends in a 0, they can both be divided by 5. But I'm going to give you another example. These can actually both be divided by 25, so that your answer is 3/8. Now, look here for a second. Our last example, when we had to make 3/8 a decimal and divide, it came out to 0.375. So here's where I'm saying, if you have some of these memorized, this would have saved you some time. You could have looked and said, oh, I just did that. That's 3/8. You would have been done with the problem. And here is my trick. There's 3 numbers after the decimal, so 3 zeros go on the bottom. At the end of the day, you must always, 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 always simplify. So that simplifying is of the utmost priority when we're doing this. So now, these are a little different. If you take a look at these, we're not just dealing with a number. Those 3 dots, okay, if we don't know by now, those 3 dots as a decimal mean they're going to go on. They're just going to keep going on and on and on. They don't stop. But you got to look at these decimals. Because if you look at the first one, that's all ones. And then you have your ... That means 1 is going to just keep repeating. So 1 is being repeated. Now, we don't do this necessarily. We don't put it over 10 because 1 over 10 is 1/10. It would end. It would terminate. Since this goes on forever and it's only 1 number being repeated, we're going to write it over 9. Okay, so one number after the decimal repeating, 1 9 on the bottom. You're right. There's a pattern to this. Go look at your second one. 12 is being repeated. It's 0.12, 1 2 1 2. And that dot 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 tells you that that same pattern is going to continue. So I can take 12 and put it over 99. And I hope some of you are sitting there saying, that can be simplified. I'm not done. And you are correct. 12 can be divided by 3, and obviously so can 99. So you actually end up with 4/33. So you should see a pattern taking shape here. Since 2 numbers after the decimal repeat, there are 2 9s that go on the bottom. Does anyone have a feeling what's going to happen on this third one? That's right. If you look at your pattern, you have 2 3 4, 2 3 4, dot dot dot. So don't worry about how big the number gets. There's 3 numbers that are being repeated. It's 2 3 4 that repeats, and it repeats in that exact order. That's important to understand. It has to repeat in the same order every single time. If that's happening, I put it over 999. Now, you should always try and divide the top by 3, because if you can always divide 9s by 3. So this one is actually divisible, okay? So you can divide it by 3, then you can divide it by 3 again. So really it's divisible by 9. But the pattern should stick. There's 3 numbers repeating after the decimal, so you use 3 9s. I like repeating decimals. They're pretty simple because all you ever have to do is see if you can divide the top by 3. If you can divide the top by 3, you can simplify. If not, you're done. But notice that word I said, simplify. Simplify, simplify, simplify. Don't just leave it as the number over 9 or 99. So here we go. It's your turn. Pause the video now and try on your own. Okay, let's see how you did. We have to be able to shift our brain. We just did repeating decimals on the last one. These don't repeat, and there's a reason why I did those together. You have 0.12. It ends. It stops right there. So there's 2 numbers after the decimal place. I read this as 12 tenths. So I put it over, or 12 hundredths, I'm sorry. 12 hundredths. So I'm going to put it over 100. I can simplify. Those can both be divided by 4 so that you end up with 3/25. Let's go look at our next one. 3 numbers after the decimal place, which is 465 thousandths. So it should go over 1,000. Okay? You're going to be able to divide both of those by 5 to get 93/200. So I threw these in there because you will see this and you'll see it on an activity you're going to do. But just because the ones place now has a number, that doesn't change anything. You still put your decimal over the same place value. So we read this as 2 3/10, or -2 3/10, my apology. So I write it as -2 3/10. I can't simplify 3/10. But what I can do now is I can do 10 times 2 is 20, plus 3 is 23. So that really I have -23/10. And right there, folks, there is my decimal written as a fraction. So let's go look at 4 6/10. So I write it as 4 6/10. The difference here is that 6/10 can be simplified. And my advice to you is to simplify that first before you make it improper. It's just going to make your life a lot easier in the long run. So if you look at it, 6/10 can really become 3/5. So I have 4 3/5. When I change this into an improper fraction, I do 5 times 4 is 20, plus 3 is 23/5. Ladies and gentlemen, I know I have gone through this fast, but simplifying is something we've been doing since elementary school. Simplifying comes in with knowing our factors and knowing what can be divided by what. If you see an even number over an even number, you can always divide them by 2 and then go until you can't go anymore. When you have a number that ends in a 5 and a 0, those can both be divisible by 5. These are some strategies we need to commit to memory because this isn't going away. This is going to be here for the long run. So let's take a look now at our repeating decimals. Pause the video and try these 4 on your own. Okay, let's see how you did. I know these are repeating. There's 2 ways we write repeating decimals. You have the ... or you have a bar on top. So what I want to show you with the first one, notice it's just a 3 repeating. Okay, those ... say, okay, this is going to go on forever. It's not going to end. If you saw it in a calculator, at the end of the calculator would be the number 4 because the calculator can only hold so many numbers. So they cut it off for you. But to do this, it's 1 number repeating. So I'm going to put it over 9. But be careful. What number did I tell you to always try and simplify them by? 3. I can divide both of those by 3 to get 1/3. That is a number to commit to your memory. 1/3 will always be 0.3 repeating. That's never going to change. Okay? So let's go look at our second one. Look at this. It's written a little different. I have 2, 3, 2, 3. Now see how the bar is over the 2, 3? That means 23 is just going to repeat. And you're going to have a 23 again and a 23 again. So 2 numbers are repeating. So I'm going to take 23 and write that over 99. Okay. Can I simplify this anymore? The answer is no, because 23 cannot be divided by 3. Okay, this one's a little different here. I have a whole number now, but I'm still going to write my decimal over a 9 or a 99 because my decimal repeats. So what is repeating here is a 5. I'm going to write this as -6 5/9. I can't simplify my fraction anymore, so I'm going to convert this to an improper fraction. I'm going to do 9 times 6 plus 5. That's how I get my 59 on top. My bottom stays what my bottom was. Your denominator, and when I say bottom, it's your denominator, that doesn't change. And the negative just kind of gets put there. Okay? So just the way we did that one, we're going to go do our last one. I really hope you guys tried these. If you didn't, pause the video now. Because if you get it wrong, there's no shame in that. You guys have the ability to figure out what mistake you made. So look at this. I now have the bar over it. See the bar again? It's over the 135. So I'm going to write 2 and 135 over 999 because that's what's repeating. Now, you need to try this because you can actually simplify it. You can simplify it to 2 and 45 over 333. Did I give you a big number here? Yes, that was on purpose. Sometimes you're going to get what you all think is wrong because the numbers are big. But don't let that stop you. Just keep going. I did this for a reason. To convert this, I would do 2 times 333, which is 666, and then I would add 45 to get 711 over 333. Chances of you getting that are very slim, okay? But take this video, go back, rewatch it, subscribe below. There's other videos on the channel of rational and irrational numbers. You'll start seeing videos of square roots and cube roots and how to estimate those. Rational and irrational numbers, those aren't going away. They're here to stay. They're here for the rest of math. So it's important to get comfortable with them. If you have any questions, post a comment below and I will answer it for you.